Almost 3 weeks you are gonna miss.
20 days. Also.
Maybe back again. Even that is reported.
Huh?
Even that is reported.
So you don't cut it?
No, so it's a upcoming reason just editing. Right, okay, then read this.
So just cut it.
There is no need. Just cut. It's easier to upload that. Right, okay, then we did this pair expansion until the differential equation we did that, right? Where is it? Where is it? What is the differential equation? Is this? No. We did the pair expansion. dt by dx something. There was something dt by dx. What was that? What was that question? I can remember last time you were doing dt by dx. First order differential equation easy to understand.
Maybe it's not me.
Is it from another? What happened to that paper? I think you wrote a different paper. Okay, just
No, no, the same.
Is it?
Yeah, the same.
I think it's a different. Yeah, I guess it's a different. Yeah, it's different.
And it's good.
Yeah. So they are pretty similar, right? The last time you had to increase this up to d cube y by dx cube up to the third derivative. But it is here, this has to be increased up to the fourth derivative of the same function.
Let's do this way.
Okay. Here's substitution. Y squared equals, is it one more t? Yeah. Dy by dx plus y. Dy by dx plus y equals x y squared. Right. Right, then we will turn this into dt by dx because you have differential equation in terms of in terms of t, right? Y is not there. Using this transformation, they have reduced that up to differential equation of t divided by this t. But then we'll find dy by dx first, right? As chain rule dy by dt into dt by dx, right? So here first I apply the chain rule, right? First I apply the chain rule in order to find out the derivative dy by dx. Then how is dy by dt? Yeah, well we know y equals y squared. Y squared equals otherwise you can differentiate this with respect to t. Otherwise you can differentiate this with respect to t. Please do it quickly.
Px is minus 2. Is it minus 2 at px?
I didn't find it. I'll check. Must be, yeah. Yeah, it's minus 2 according to this book. It's minus 2 here. Is then
So differentiation is minus 2.
correctly.
Differentiation is minus So I exists e to the power minus 2x.
Yeah. Using this transformation, we use differentiate. I think I explained this last time, right? This is differentiated with respect to x. This cannot be differentiated with respect to x, and as per chain rule, is differentiated with respect to t, and t is differentiated again minus 1 over t squared, then dt by dx, right? Okay. Then dy by dx is nothing else minus 1 over t squared. I think I explained this part, right? We could reduce that up to that equation, differential equation, and use that differential equation directly. This is reduced up to dt by dx minus 2t equals 2x, right? Okay. Now this is according to dy by dx plus d of x into what? Y equals q of x. And instead of y, we have q, right? So then the c is minus 2, right? P of x equals minus 2. Then integration factor, I of x is e to the power integral e of x dx. C is e to the power minus 2 integral, and I of x this becomes e to the power minus 2x. Integration factor is e to the power minus 2x. No need to put the constant, right? So last time when you were asking that question, individually, generally I said that if it's an non-definite integral, I explained that you have to put a constant, but here it's not needed because it's within that. Otherwise, we can add that constant, right? So if you're not given a singular solution, you can't find that constant exactly. We can multiply both sides by the integration factor dy by dx into integration factor p of x into y into I of x into q of x. This is t, right? This is minus 2, and this is t, right? Integration factor 2x into e to the power minus 2x, right? E to the power minus 2x, right? So this is the derivative of integration factor into t, right? With respect to x, this is 2x e to the power minus 2x. You can solve this now. E to the power minus 2x, 2x into e to the power minus 2x dx. We can integrate both sides. Right? We get this one.
So is it then minus 2x?
Yeah, e to the power minus 2x into t, isn't it?
That's also minus 2x.
What? Integration factor is e to the power minus
Right hand side,
Yeah, right hand side.
that's minus 2x.
What?
Minus 2x.
Which one?
Yeah, that's minus
Right hand side is minus 2, is
Yeah.
it? It is minus 1, okay. Then you can get this answer e to the power minus 2x into t. Can we integrate this at once? Directly? Can you integrate this directly?
minus 2x plus 1 over.
We can use integration by parts, right? We can use integration by parts. Integration by parts.
I'll use this.
What? How do we integrate? What was it that we integrated this?
Minus 2x.
No. This is an exponential function. It is not a usual one like this. You have done two mistakes, two wrong integrals you applied. For this one only we can apply that one, right? If it's an exponential one, we can't treat it as an index. Right? It's another function. It's an exponential function. Is the Euler sum. This is an exponential function. It's not a function like this. This is like a polynomial, but this is a Euler's number, and this is the exponential. And the other thing is when it is multiplied with x, you can't apply that individually. That's it, right?
When the power is multiplied by x, you can't apply.
No. So for this one, definitely we can't apply. Anyway, we can't apply that for because this is an exponential one, right? This is an exponential one. This is a polynomial one. If it is like x to the power in order level, we have these functions. But this is an exponential.
Can we integrate x to the power 3x?
True? No. So in such cases, we have to use methodologies. Some approximations can be used such that otherwise.
Then how do you integrate this?
Okay, this one. Yeah, integration by parts. This integration by parts, for example, if you are supposed to integrate, let's say, we will get the same, right? E to the power x into e to the power minus 2x dx, right? This is general form. Integral u dv equals uv minus integral v dv, right? This one, you remember that. We had select what are the uv and then u into v. Then, yeah.
I never did.
You never did. We'll go through some example questions. Okay. This is applied once the function cannot be integrated at once, and the major thing is if these functions are two different functions. I mean, maybe here this is an algebraic one and this is an exponential function. They are two different functions. So in such cases, it's quite complicated. Therefore, we can do that using integration by parts, right? So first of all, I will show you it is not required to be two different functions to apply this integration by parts, right? So when you get that type of function, you may apply this, then you can reduce that complexity, reduce the complexity of that question, right? Then, but even for simple integrals, we can apply this. For example, let's see what about this one, right? If you try to apply this, you have to first select who is u, who is v. Let's say this is u, this is v. Right? There are different combinations. This is simplest combination, right? Simply we can keep this as u and this is v. Then u into v is x into x minus. When you switch them together, what's going to be itself, right? Integral x dx, right? Then you can put this into the other side. Then it becomes 2x dx integral x dx. This is x squared, right? We can divide both sides by 2 in order to subtract this one, and there must be a constant as well. So what did we use here? Did we use that one? That general format? Did we use general format? No. We didn't use. If you use that, you could use that directly at once in plus 1. Since n is not equal to minus 1, here n is not equal to minus 1, it is 1. You can apply that directly without going through this integration by parts. So when we use integration by parts, first of all we have to identify what are these u and v. I selected this u as this one and this is v. This is formula, right? And then first of all we can note down this, right? But there is no point of applying this integration by parts for such simple integrals, right? This is dedicated for some complicated integrals such that with different two different functions, maybe more different functions, right? Yeah, first we can write this down, then we will do a couple of questions regarding that.
I'll do this first.
Yeah, in some questions, even in differential equation questions, in some cases we need this integration by parts. If we are failed to respond on this problem, then we can't get the final answer, right? What is
Should we always take minus 2 out? Should we always take minus 2 out?
Yeah, minus 2 is a constant.
So there should only be a x term there.
You are going to work out for this one directly.
Yeah.
Alright, okay. In this case, I want to show you some examples. You know, you can get the result because these are very simple, right? These are very simple. There can be different combinations. I will show you that, right?
I'll do this first.
Right. Do this first, right?
Do this.
You can't do this at.
I'll try.
Alright, we can try. Okay, I'll get you this. Okay. These are two different functions, right? So there is an priority order. I lay this ethical one, noted out, right? Like priority order, right? So inverse function, this represents, this stands for the inverse function, this stands for logarithms, and this is arithmetic. Right? These are very easy. Isn't it? You late always, then you can keep
What is
late, right?
I late.
So this C is for trigonometric, and the final one is for exponential. What does this priority order say? Is when you run down through this priority order, the capability of integrating that is going to be increased respectively. Like exponential functions can be integrated more easily rather than trigonometry. They can be integrated more easily rather than algebraic. So you have two different functions. You look at this. This is exponential and this is algebraic. So this is more easily integrable rather than algebraic. Right? So therefore, in this case, you can't directly find u and v, right? Because they have been hidden, right? They have been hidden in two different parts. Look at this, please. We have many different combinations. For example, someone can select this is u and this is v. One of the combination u equals x into e to the power minus 2x and v equals x. But that doesn't help us because even the complexity is there still. We can keep doing that, but we are going to start somewhere. So therefore, we have to find the correct combination, right? Okay, let me explain. Another combination. You can say this is dv, right? This is dv, and this is u, right? Another combination, right? Isn't it? U is e to the power minus 2x. V is not v, but dv is x into dx. So in this case, this doesn't give us v directly. We have to derive v. We have to find v. But it doesn't matter. We can do that. Once we integrate both sides, we get v. Right? That's one of the combination. What's the other combination? So there are some more. Right? We can arrange this further. E to the power minus 2x dx. We didn't keep this as dv. We can keep this as dv and this is u. Right? So who are the correct combination? Right? So how do you say that? dv is e to the power minus 2x dx. What is the correct combination among these? Who's that? So you can see here, if we select v as dv as
So d is also constant, is it?
no.
No, I mean there.
It represents the operator. No, it's not a constant. It represents the operator. Like it's coming up with delta, the smaller part where this delta x tends to c. So it is formed with that.
And how is this equal to d?
dv, this part is like, when we compare them, this part seems like dv. dv equals like this part.
How?
Compare that. If this is u, this must be dv. I know that when you think deep and deeper, you get many questions how it's going to be. Because you should know the deep meaning of this integration. Not anything that much, I think, here. Because here we need to integrate that finally. They are supposed to show that, right? They won't expect that. They want us to integrate that only. So when you compare this part with this, it seems like directly dv. Why can't you find x, v, isolate directly? Why can't we solve for v?
V is.
No. Who's that? Because we are going to split it by this.
V is e to the power minus 2.
No. dv is e to the power minus 2x dx. That part, right? Because we have selected this x as u, right? This is more fair because when we try to find v, this is dv and this is e to the power minus 2x. You can see this dv we selected is more in the priority order that is important, right? Respective. So we can integrate both sides. Then we can easily find out v.
Integration of that is.
That is
same.
itself. E to the power minus 2x, and we can divide it by the derivative of this, which is minus 2. Right? Then you can get v. Then you can say, and someone can ask, even in this case we can find v. Even in this case, even in this combination, you can find v. Isn't it? But in this case, you can see when we Even though both can be integrated in this case, but I prefer this one because we can get rid of that, because we get rid of it's in the same loop, right? It's in the same loop, and it prevents from complicating this expression. But here, this form x squared over 2 is going to be complicated further, right? When you go through this way. But here, this v is e to the power minus 2x over minus 2. It's complicated now, right? Alright, okay, we'll go through this combination. I selected that because in this priority order, this is important when comparing this. Why did I use this one?
So what is the du?
Yeah.
What's the u?
Not du. U is directly x. U is directly x.
So after finding v and u, now what?
Yeah, okay. Good question. Yeah, I'll clean this part, right? Because these are not needed. I show you this combination, but it's not needed, right? I'll clean this, I'll keep on this correct combination, right? This is correct combination. This is correct combination of that, right? This is v. Could you understand? I selected this as u, and this is dv.
Yes.
Also, this, right? Okay, here, look at this. So, then you can use this equation, please. You will use this equation. Who is u? U is x. Now you can keep doing that yourself, please. So, and there is another way, even without applying this integration by parts, we can do it using another substitution, right?
So when integrating e to the powers 1,
e to the power minus 2x, then you find v. Then you have
how to integrate? How to integrate?
Yeah, it's a general format of this integral of what? The exponential is it's same as e to the power x, right? So change. These are already constant.
Can you give another example where it's not just x, maybe like
Yeah, okay. Let's say this is k.
kx plus
Kx plus l is a linear one, right?
Yeah.
It should be a linear one, otherwise we had to go through, Taylor series, right? Otherwise we have to use such approximations, right? Or otherwise we have to go through substitutions. But most of the time we get on these things, right? If it is linear, you will call kx plus l, and this should be divided by the derivative of this. Who's the derivative of this? K. That's all. Right?
That's it?
Yeah, that's it. That's what is happening. This is e to the power minus 2 and it is divided by the derivative.
But if it's 2e to the power kx,
2 into
2 into e to
yes,
the
2 is a constant.
just take it up.
Yeah, just take it out simply. Because it's a constant. Also, it's multiplied with that. Did you find
Yes.
let's do it quickly, please. So hope you all get this now. We found we selected u as x into, then v is e to the power minus 2x over minus 2, then minus v dou we have switched it, right? So this could be applied because you found v right here. Here you found v. Otherwise, within only dv we can't do that, right? Because it requires finding v is required. This is
This.
right. Okay, then we switch that. Right, okay. What happens now? Yeah. Again, minus 2 is taken out, x into e to the power minus 2, x to the power minus 2. This becomes 1/2 integral e to the power minus 2x. Minus 2x to be interpreted once again, right? Here, this one. So, the integral of this. This is the integral of this. But we are supposed to integrate meanwhile the differential equation. Isn't it? Now we have already almost integrated here. This one, the integrate of this.
That's minus half.
Yeah, minus because this minus
Oh, that's
sign
minus.
and this minus 2, it becomes plus half. Do it quickly. Yes.
We know.
Correct, right? This becomes e to the power minus 2x or minus 2, then minus 1/4 e to the power minus 2x, and plus yeah, the rest we can do at constant, right? This is minus x e to the power minus 2x over 2. This is minus 1/4 e to the power minus 2x. Right, you got that? You got that here? We can substitute over there, right? We can substitute over there. The most interesting part is these.
That's it.
We found that. We have any constant here. Minus 2 into minus x e to the power minus 2x over 2 minus 1/4 e to the power minus 2x. Then C t e to the power minus 2, C base object t. Right? But the thing is, we took a substitution because we could not apply that directly. We went through a transformation, so we had to get rid of that because we had to solve for this solution should be in terms of y and x. Right? This is in terms of t now. You can subject t equals 1 over y squared. Instead of t, we can substitute 1 over y squared.
So y squared equals e to the power minus 2x over.
Yeah, you can take out e to the power minus 2, then you can cancel off that, but yeah, in this case you have that part there. Then the other one is
Should I substitute minus 2 inside?
what minus?
No,
Yeah, you can expand.
No need.
Expansion. Yeah.
No need.
You can expand it.
Why?
You can expand x e to the power minus 2x can be taken out. That can be factorized. This is 1/2 then plus c, and t is 1 over y squared e to the power minus 2x. This is y squared. Okay. If you not see the solution, you can solve this and find the singular, or find the constant. Right? Okay. Shall we move to the next question? We move to the next question, please. Shall we do another integration by part question? So otherwise, meanwhile we are working out for these differential equations.
So after this paper,
Yeah, okay.
now this is.
There are many questions in this book. After that exercise, did you complete that?
This.
Did you?
This.
Sure. I think you did. Pretend like an integral, right? So you should integrate it. So let's see the question. In statistics, what are you doing these days?
Statistics at school. I don't do.
This time? You don't do?
No, I don't do it at school.
Oh, but you have started.
Yeah.
Oh, you do in beginnings. What are the things you discuss in beginnings?
Physics.
Let's know all about physics. There are extensible strings, then anything, all the motions and equilibrium is extensible. I mean, extensible. In physics, almost it's there in extensible. Finished. Oh my god, this is being recorded.
It's not recording.
It's being recorded. What's the question? X plus 1. X minus 3. X plus 2 is equal to less than 1 minus. What's this? 2. 2. Oh, x minus 3 is equal. Alright, okay. Then you can get common. You can put everything into the other side, right? Shall we?
After getting common denominator, what?
Yeah, after getting common denominator, you can simplify that. Right?
By expanding.
You can expand the numerator. And when it comes to this position, this becomes plus 2 into x plus 2 because that has no term. But this becomes minus into x minus 3, x plus 2. Right? So we'll simplify that quickly. I feel like it's better to put everything to the other side. It's okay, it doesn't matter, right? This is minus x squared, minus x squared. This becomes 2, 3, that's 3, then minus 3, it's minus 1, plus 1. This is plus 1, then 3, plus 4x, isn't it? Check that again. Minus 3, minus 1, plus 1. Yeah. How much is the constant? What's the constant? Minus 6, plus 6, plus 6, plus 10, plus 1. Right? Oh. Seems like it cannot be factorized. We cannot factorize that.
1, 7.
You can divide both sides by negative when the sign is not to change. What's this? Check the discriminant of this. Discriminant is minus b squared minus 4 into minus 4 into a into c. What's that? 4 into 4, 16. That's positive, right? This becomes positive. This can be. You got the same?
Yes, minus x squared plus 4x plus 11.
Plus 11, right? I multiply both sides by negative, right? And I get this. We can factorize this numerator, right? But still, that can be the discriminant is positive.
So there are factors.
Are there factors for this?
But root, the root factor.
What are the root factors?
2 minus.
Yeah, irrational.
So we can't take it.
No. We have to consider that part. Yeah, it has to be considered. Because when we plot it, yeah, we have to consider that part. Good, same answer, right?
Yes.
Right, okay. We'll do those factors. What are the we said it will proper, right? Minus, I said this as 1, then minus 4, minus 3rd. This we start to the other side. X minus 2 plus, so 15. The other one. 2 minus, so 15 is equal to 0. Minus 3 plus 2, right? Then please do it quickly. What are these decimals?
What's that line?
Number line, we find these regions.
No, that line.
Which one?
Above.
No, it's a kind of right. It's kind of right. Parents is instead of that parents.
Parents.
Yeah.
Parents.
No, parents. Then it's minus 1 point, minus 1.87, like G is 2 minus square. So approximately minus 1.87, right? The other one is 5.87, which is here 2 plus square root of 15. The other one is 3. 3 is in between. In between these two. 3 is in between these two. Right? So they can be equal. But this cannot be equal, right? This cannot be equal, right? Because that is in the denominator. So what about this minus 2? Minus 2 is
Calculated.
right?
So did you get a calculator?
Yeah.
Did you get a calculator?
No, I can't get one.
Why?
You want?
Sunlight. You get it.
Yeah.
Sunlight.
No, then it's with one of my students. Why?
You gave it.
And no, then I think, yeah, I'll pay. Why?
Because it's been gone for a long time.
Then we will check new one, right? Then share that platform with me. I'm interested in that CGP 50 something, CW 50. And with the color display and there are many functions. I think even Maclaurin series and all the functions are there. So it will be a good experience. And I think it's around 50,000 or something. In AliExpress.
Aliyah.
Okay, this is you can find only one here, right? Because it's going to be switch. You can substitute less than minus 2, maybe minus 3. Minus 3 is approximately 5 something. So this is going to be negative. Minus 3 is going to be definitely negative. Oh, right. Minus 3.
It's 0.
What?
It's positive.
This one?
Yeah. No, I mean the whole thing is positive.
The whole thing.
Positive, negative, positive. Negative.
Yeah, this is positive. Okay. Otherwise, you can insert this expression into your calculator and the default value can be edited in the calculator. Default value of x, you can register x as something less than minus 2. Then you can insert everything as a general algebraic expression. This is minus 1.
So greater than or equal to 0 means it can be equal to minus 2 also.
Yeah, it can be equal to minus 2 also, but the thing is, since this is a denominator, that can't be, these two can't be, because that can go up to infinity because there's going to be
So just less than.
vertical infinity, not then around these vertical asymptotes we can't get the equal sign, right?
So just less than minus 2.
We are looking for greater than this one, and this one, right? But these are about these vertical. Yeah, this is what the vertical asymptote. This is what a vertical asymptote. So you can't include equal with 3, right? X is less than minus 2. Union X is X exceeds 3.
It can be equal to 2 minus 250.
Yeah, I can be. But here that won't be equal to minus 2, right?
The right union.
Yeah. Finally, let's check the numerical consistency of these answers. So,
I did this. Now what? How do I deal in W?
transformation. You can see subject.
I subjected. He said.
Given that training maps the imaginary axis in the plane to the circle C in the W plane determined. But it's easy to keep this thing in two different projections. Right? Z is x plus iota y, right?
Okay.
Z is x plus iota y and W is u plus iota v.
Okay. See, they are all constants.
Yeah, I think there
You
are.
can say W is also x plus iota.
Yeah, z minus iota over z plus iota. This is sub z plane. Z is generally represented by x plus iota. P and W is another plane. This one in the imaginary axis. In the imaginary axis, this is in the imaginary axis. Imaginary axis in the z plane to this circle C. T maps the imaginary axis in z plane. In z plane, right? This is yeah, we have two different things. I think you subjected z here, right?
Yes.
Shall we use all the methods? But finally we will catch the most convenient way, right? This is wz plus w iota z is taken this side. We have to subject z final, right? But this is the other side. Otherwise, z minus wz is w iota. W plus 1 iota z equals what did you get? 1 plus w iota over 1 minus w. Did you get that? Something different. So what's wrong with it? There's something wrong with the calculation. What is it? When you subject z, who is that?
Minus W minus iota W minus. That's what I got.
Iota is taken out, w plus 1, isn't it? Z 1 minus w. So you divide both sides by 1 minus w. You got this?
By W minus 1.
The minus sign is here in numerator.
By W minus 1.
First one divide.
Yeah.
Wz plus w iota equals z minus iota. Okay. Put this z in the other side. Then this iota can be taken to the other side. Right? W iota plus iota equals z minus wz. Right? Z is taken out. Then z into 1 minus w equals iota is taken out, w plus 1 into iota. It is, yeah. Z is now x plus iota y. This is iota into u plus iota v plus 1 over 1 minus u plus iota v. Right? So you can simplify this further, right? We can becomes I squared, which is minus b. I squared is minus b. I squared b is minus b. This is u plus 1 iota. U plus 1 iota. This is 1 minus u minus iota b. You can multiply both denominator and numerator by 1 minus u plus iota b. Now this is 1 minus u plus iota b, right? You can multiply both denominator and numerator by the conjugate of it, right? Conjugate. What's wrong with it? This one? Let me check. You can cross. Actually, this one is easiest way, right? Don't use this method. It's what's that? You could do everything. Yeah, okay, right. You kept. This is one, right? My God.
I think it's higher.
Oh, everything is wrong. Everything is this one. You could tell me earlier. Oh, why do you say that? First thing. Right. Right. This W plus I.
Can I see the cameras?
W plus what?
Can I see the camera?
Yeah, this is broken, I think.
Is it?
Yeah, now it's broken.
It works good.
It doesn't work properly. 1 minus W. It's 1 minus W. Given this z equals.
Why does it work?
This is work properly. Oh, what? Now it's. Yeah, now it's working. Yeah, I thought that it has been working.
So how much is this?
It's on. 20. Lost this.
Now how much?
I mean, 4 years, 4 or 5 years back. No. So it's cheap, I think. And now you can find these kind of.
Now can't find.
I think can, but yeah, it's just good for the price. It's really good.
I like this type of.
Right, okay, let's do this, right? Complete this first. First of all, let's complete this quickly, please. Hurry up, please. You got this, right? Then in this plane z, x plus iota y, right? In this plane, you get u plus iota v. Then when we put everything together, this is v plus 1 iota, 1 minus, this one is 1 minus u. After we substitute this becomes minus iota v. You got it? You got this one? You can multiply both denominator and numerator by the conjugate.
Is this the easiest method?
No.
What's the easiest method?
No, yeah. Okay. We'll check the easiest way. Then minus iota v, we can get the conjugate. We can multiply both denominator and numerator by the conjugate. Right? This is known as the conjugate. It's defined for complex numbers, right? Okay, now we can get rid of this part, right? It's going to be what? This is x plus iota v. Even though we simplify everything, we need only the imaginary part, I think, because the given that the t maps the imaginary axis in the z plane to the circle in the w plane. Imaginary axis of z, so it means y. We have to check this y component, right? We are doing everything for finding y, but no need to do everything here, right? I'll show that was the easiest way. First of all, we will do this quickly, please. I want you to do this quickly. I minus 1 minus u squared. Always when we multiply this to 1 minus u squared, the difference between 2 squared, this 1 squared minus.
So easiest method.
Okay, I'll show that. First of all, please do this, right? Before finding the easiest way, you can go through this, right? Right. Okay, then we can simplify this one. This is u into 1 minus u. This is minus v, because I squared is minus then v plus 1. The other part, who is the other part? This one, the iota part. That's the most significant, right? Iota v plus 1 into 1 minus u